So there's direct variation and indirect variation. And the way you're going to tell the difference between the two is, I guess one potential way is you think about the two variables that you're asked to study. Do the two numbers increase together, or does the increase in one number cause the other number to decrease? If they increase together and therefore decrease together, that's a direct variation. If one increases while the other decreases, that's an indirect variation, okay? And that's just for like the problems of your algebra class. It's not like a... Let's check out an example. Too small. Not a real Goldilocks moment. This one's too big, this is too small. Okay, so this example here. The length of a roll of tape and the number of 6-inch strips that can be obtained from the roll. So there's two variables. The length of the tape, that's a variable because that can fluctuate. And then the strips, the number of smaller strips, that's the other variable. One could be our x and one could be our y. So the way we could make this, we could actually, before we even try to make an equation, let's just play with some numbers. If there's 36 inches in the length of the tape, then the number of strips we have is 6, right? Because 36 divided by 6 makes 6. Let's actually start with something smaller. Let's say the length of the tape is 6 inches. That means we can only get one small strip that we need. If there are 12 inches in the roll of tape, then since each one is 6 inches, we can get 2. If there's 18 inches, then we can get 3. So what we're seeing is that these two rows that I've constructed here are increasing together, right? As this row goes up, this one goes up. So that is implying it's a direct relationship. And if you want to see the equation for this, the number of strips we make is 1/6 times x, the number of the length of the tape. Okay, another example here real quick. The speed of an ice skater and the time it takes him to run, speed of an ice skater. This is a little funny. I took this directly from my math lab. The speed of a skater and the time it takes him to run an 8-kilometer race. I guess, a skater, you might take him out of the rink and say, okay, now go run a race. I wonder if they meant the time it takes him to skate an 8-kilometer race. But either way, there's two variables. The speed of the skater and the time to run the race is the other variable. So let's just do the same thing we did before. If the person is running at 8 kilometers per hour, that's just one speed I made up. That means it takes them 1 hour to skate the race or to run the race, whatever this problem is asking us to do. If the person's going at 16 kilometers per hour, then that means it's only taking us half an hour, 0.5 hours to complete the race. Right? You could do another one. You could do 24. That the amount of hours should be shrinking again, right? This is 0.333 hours. So this is an example of an indirect relationship. Okay, and the equation for this, let's see, y would equal 8 divided by x, where x is the speed that the person is running or skating, whatever they're trying to do with this problem, and y is the time it takes them to complete the race. Okay, so I hope that gives you an idea of what to do with direct and indirect variation.